It's really great to be back in Cleveland. I can't believe that 25 years have gone by since I graduated from this wonderful institution. It's just phenomenal to think back how much has changed, and the trajectory has been ever onward and upward, and I can't help but think part of that was because I left and that allowed. But actually, the one bone I do want to pick with you Clevelanders has to do with sports. So for many years, we in San Diego rested very comfortably knowing that there was a city, a very populous city, that had gone without a professional sports team championship longer than San Diego. And that, of course, was Cleveland. Until LeBron and the Cleveland Cavaliers, can I say LeBron anymore here? Or is that, okay, anyway, until the Cavaliers won the NBA championship. And then Cleveland left the title of longest suffering city without a major league championship team to San Diego. So we have not had a championship team in San Diego, thanks to you guys. But I always say, the easiest job in the world is San Diego meteorologist, but the hardest job in the world is San Diego sportscaster. So, we got to make up for the wonderful, lovely weather that we have in some form or fashion. So I'll take it. But it's nice to be here, and a lot has elapsed. And as I said earlier this afternoon, a colloquium came at the physics department. A lot of what I'm able to have achieved in my life and the steps that I've had along the way, as my book details in a memoir type fashion, is thanks in no small part to this wonderful institution. And I'm just so tickled that I get to come back here and speak to so many new friends and older friends and people I get to call colleagues and give a talk in the very classroom where my physics career was given birth to. So I want to talk a little bit about a very mysterious, very interesting character, Alfred Nobel, and how his life and death actually intersected with my life, and hopeful not death for many, many more years. And that is Alfred Nobel and what he did with his eponymous prize, the Nobel Prize, which I claim is the most effective form of public relations posthumously beyond the grave that has ever been achieved. And he did so courtesy of another invention or another association with death, and that was the creation of dynamite. So Alfred Nobel famously created 355 patents, and I point out that 353 more than I've ever created, but I'm getting there slowly. And one of those, and the most profitable by far, was dynamite. And dynamite was high tech in the 1860s, so much so that it was during the boom in the westward expansion of the United States, the railway system, et cetera, that was enabled in no small part by Alfred Nobel's invention of dynamite, which in itself was precipitated by many, many close encounters with death in the Nobel family, the most personal of which was his younger brother, Emil, who had been toying with nitroglycerin, trying to make a stabilized form of explosive that could be used to be transported across the world and possibly to America, and failed miserably and spectacularly fashion. He ended up killing himself and many people in the laboratory that the Nobel family had in 1861. And 3 years later, Alfred continued to be obsessed with this creation of an invention that would allow construction using chemical inventions, and that became dynamite. So he originally wanted to call it Nobel's safety powder. So he was very aware that you could make a lot of difference by choosing a proper name. And he knew that people associated the Nobel name with death. So much so that in 1888, he had a surreal experience, which is that he was walking around the streets of Paris, and he saw a headline that declared him, Alfred Nobel, to be the merchant of death. The single human being in history had been responsible for more death and carnage than any other individual. And it celebrated his death. And he could only take a little bit of glee in knowing that he was reading his own obituary, so it couldn't have been him, right? So the reports of his demise were slightly exaggerated. And in fact, it was his older brother, Ludwig. Ludwig had died, and in dying another brush with death, Alfred himself had a revelation that is similar to the one that Ebenezer Scrooge had or George Bailey had in It's a Wonderful Life, which is that he got a vision, a revelation of what the world really thought about him and how he would be remembered after he was gone for real. So this was over-exaggerated, but he knew this is the way the world... So he revised at that time that his legacy would be for peace and for creation of events and inventions that would better the world. And in doing so, he endowed the Nobel Prize. And I claim the Nobel Prize and the will that endowed it are really the most famous of all wills and testaments. And in the second of the two encounters, in which I've lost the Nobel Prize, so I've had the opportunity to lose it twice in two ways that I'll explain throughout the talk. But in encountering it and studying it in some depth during the course of the events I describe in the book, I came to see it as very much distorted from the Nobel with L-E vision that Alfred originally maintained for it. And I hope to convince people that this medal, as good an effect as it may have, I mean, we have buildings, dormitories that my friends lived in on campus, named after Nobel Prize winners. There's two of them, right? There's Cush Hall when I was here, and Michelson, of course. We went to a restaurant today, Michelson Morley. It's lovely and delicious. Didn't exist when I was a student, but glad to see it made it there. In San Diego, of all places, you wouldn't associate with the Nobel Prize. We have a street called Nobel Drive. It intersects with another street called Le Bon Drive. What's Le Bon backwards? Nobel. It's written into the streets of San Diego, California. Why is that? And I'll explain some of the connections there. But it made me think about the impact, the outsized impact that the Nobel Prize has that no other award has. Not the Oscars, not the Latin Grammys, not the Emmys, nothing compared to the Nobel Prize. And it really harkens back to an earlier time in history when science was done in a very different way than it's done today. And part of the book is to agitate for changes in the way it's done. But certainly someone who would have won the Nobel Prize had it been offered 400 years earlier was a man by the name of Galileo Galilei, who he utilized the telescope for the first time for astronomical purposes. And what he did with this telescope is turn it into a lever. And this lever moved the entire Earth, figuratively. It displaced it from being the center of the universe to a much more pedestrian location in the middle suburbs of the solar system. So it made it, instead of being the most important location in the universe, it made it an ordinary portion of the universe, namely the third rock from the sun, as the sitcom used to be called. And in doing so, Galileo was able to transform humanity's view of how the universe was arranged. He did so with a refracting telescope. And the telescope became a tool to better inform and educate humanity on its proper place in its regard for itself, a dose of cosmic humility that continued for centuries, up until a refractor by the name of Bicep started to ply the skies over the southern hemisphere and the South Pole. I'll describe what happened in those events. Directly connected, the DNA of our telescope is exactly the DNA of the Il Maestro's telescope, Galileo's telescope. About a month ago, I was at Williams College. I got to actually touch and take home. No, I didn't get to take home a copy, but it was tempting. This is Galileo's Sidereus Nuncius, which is a publication I pointed out he self-published without peer review in a matter of weeks in 1610, after making observations of the planet Jupiter and the 4 stars that he claimed were in orbit around it, like vassals surrounding a king, or an entourage surrounding Kanye West. But in any case, these stars seem to orbit around Jupiter, and he clearly identified what is known to be the case today, which is that Jupiter is like a miniature solar system of its own, with every right to call itself the center of its own existence. And that disproved the notion that the Earth was the center of the solar system, or the center of the solar system. And instead ushered in was a notion of the universe as being centered on the sun, or providing evidence for that. I spoke a little bit today about what I consider Galileo's biggest blunder, which involves this little tiny collection of stars, which you may be familiar with from your car, called Subaru, or the Seven Sisters. But it really illustrates the power that the most humble substance in the universe, dust, this pollutant that many people believe is nothing but detritus that gets in the way of all the good stuff in the cosmos. It actually created an illusion that Galileo himself, the first astronomer to use a telescope for astronomical purposes, he too stumbled upon this substance called dust. In this paragraph here, he says what he observed in the Milky Way was basically conceived by him to be the entirety of the cosmos, comprised of stars and stars alone. And this was done in furtherance to bolster the Copernican hypothesis. In other words, he wanted to say that not only was the Earth just a planet amongst 6 other planets, or 5 other planets, but so too was the sun just a mere star amongst the millions of myriads of stars that were surrounding us. Of course, we know now that's not true, and actually the Pleiades, or Subaru, is actually surrounded by dust in a nebula. And in fact, Galileo's conjecture was shown to be wrong only in the last 100 years, when astronomers took observations of the Pleiades nebula and showed that it was exactly identical to the composition of the starlight of the stars that surrounded this glowing nebulosity, as it was called. And actually, we know now that these stars are formed in these stellar nurseries, and not just stars, but planets too. In fact, the Earth is nothing but a giant ball of dust, as I'll point out later, that's orbiting around the Earth, reformed after being exploded out from a star that existed perhaps 5 billion years earlier than the sun was formed, or 5 billion years ago. So as I said, the image that you should think of your mind of how the solar system was arranged, the solar system being effectively the entire universe in the 1600s, was one that went from being Earth-centered, geocentric, to heliocentric. It didn't come easily. When first Galileo postulated this idea, or evidence for Copernicus's idea, which Copernicus had in the 1500s, but this was the first evidence provided by a refracting telescope that moved the Earth from this position of being the center of the universe in a very stark and unique way that was essentially inarguable. And at first, it brought Galileo a lot of attention, and he needed attention because he had at least 2 illegitimate daughters. There's a great book by David Sobel called Galileos Daughter, and it details how he went to great lengths to be near his daughters who were, born out of wedlock, which made them illegitimate, and so they had to become nuns. And they were, in later life, when he was in prison, as I'll explain, he was allowed to live fairly close to them, and that was sort of a nice bone that the Catholic Church threw to him. And at first, you see Galileo here with a dark beard, so you can tell he's a little bit younger. He's probably about my age, late 40s at this time in 1610, 1611. He wanted to make money. He had no small amount of bills to pay, and he had a laboratory that he had to support. Nowadays, we professors know about graduate students. They had their assistants back then as well. And this telescope, he wasn't willing to share the properties of how it worked with anybody. Even Johannes Kepler, who had given a lot of data to Galileo that led him at least on the path to conjecture Copernicus was right. So Galileo would say, when Copernicus said, I'm going to be in the neighborhood, Galileo would say, I have a cold. I mean, there are actual letters written where Galileo says, it's going to be cloudy when you're here next month. But they were very possessive of their data. And we scientists are not so far from that nowadays. We like to have and kind of be possessive over, quote unquote, our data. And sometimes that can have disastrous consequences. So here he is, Galileo, showing the Venetian Senate and the powers of the telescope to potentially gain advantage on their enemies who would attempt otherwise to surprise them by coming over the horizon in the Venetian lagoon and attacking the state of Venice, the sovereign state of Venice. On one hand, Galileo profited greatly. As I pointed out today, he became the envy of professors everywhere because the Venetian Senate basically enforced upon the University of Padua that they had to hire Galileo and permanently made him tenured. Okay? So instantaneously, he goes from no professorship, tenured full professor, and they gave him twice as much startup money as he requested. So this is a dream of all professors everywhere. But it was actually a dreadful thing for him because it brought him within the sphere of influence of the Vatican. So at first he made a lot of money. He didn't build telescopes. He refused to divulge how he made the telescope. He kept it as a trade secret. Like Apple is not going to tell Google how they make their iPhones. They keep it as a trade secret. But he knew he could write books. And books he could roll off the printing press himself, and there are several hundred copies of Sidereus Nuncius still available. And so he actually went on a miniature book tour within the state of Italy, and it brought him no small shortage of attention. There we see Mrs. Kanye West signing books. John, that's Kim Kardashian, I think. But because he was now in Padua under the influence of the Vatican sphere of influence, not more than a few hundred kilometers from Vatican City, the Pope eventually got wind of the teachings of Galileo and ordered him to stop teaching it, which he didn't do. And years later, about 3 decades later, after the Sidereus Nuncius, he published a dialogue. The full title is The Dialogue on Two Chief World Systems, in which he crafts the book as a conversation between 3 different people, one representing him, with a name that roughly translates into the brilliant one, Sabati, and then he put the words of Aristotle and Ptolemy in the Pope's alter ego that he named Simplicio, which means simpleton. So that wasn't so good. That would be, me, working here and saying, President Snyder, calling her Simplicio. That's not a good way to get tenure, but it was worse for him. So he actually had to cower. Now you see him with a white beard. Later on in life, the last 9 years of his life, he was sentenced to house imprisonment. Of course, he was a couple miles away from his 2 daughters in a convent. But the view of the cosmos that he ushered in was, in contrast to the Earth-centered reality of the cosmos, what Galileo realized is that it did appear as if the Earth is the center of the solar system, which was the universe, and so too does it appear the Earth is the center of many, many structures in the universe. So we went from thinking we're the center of the solar system to realizing we're just a planet orbiting the center of the solar system. Then the next stage of cosmologists said, well, we're the center of the galaxy. The Milky Way galaxy is centered on the Earth or the sun, even though the sun is the center of our own solar system. The next step was, is the universe expanding, and are we the center of the universe? And nowadays, the extension of these debates now revolves around the question, are we the center of the multiverse? So it's not that there's just another 7 planets besides the Earth, or that there's another 100 billion stars in our galaxy, or that there's 100 billion galaxies in the observable universe. It's that there's an possible infinite number of other universes in the multiverse. And the extrapolation, if you're a mathematician, you just keep extrapolating. And so we're not the center of any of those things. So we're not the center of the multiverse either. And the multiverse is where things get really weird. So hopefully we'll chat a little bit about that. The view of the cosmos that we have now extends all the way back to the earliest light that a telescope or radiomagnetic detector can see, called the cosmic microwave background radiation. That goes back to about 500,000 years after the Big Bang. That's the origin of that light. It's the oldest light. Now, 500,000 years out of 13.8 billion years is pretty good. But we physicists are greedy. We want to go back to the very beginning of time itself. And to do that means you have to use a different form of light, or perhaps a different form of radiation altogether that's not electromagnetic in nature. And to do that, colleagues and myself realized we could do that using waves of gravity instead of waves of light. And gravity goes through everything. Gravity from the moon goes all the way through from San Diego to Indonesia and creates high tides on both opposite sides of the Earth. That means gravity is going through the Earth. Gravity goes through everything. It's the weakest force, but it has the longest range effects. So we realized with colleagues and friends that you could go back further than the first 500,000 year period in the universe's evolution, for perhaps a trillionth of a trillionth of a trillionth of a second after the Big Bang. And that would be the so-called period known as inflation, which I sometimes colloquially call the spark that ignited the expansion of the universe, the spark that lit off the Big Bang. So astronomers discovered this in, of all places, New Jersey. So I'm a New Yorker, so we get to make fun of. So I'll say, this is the best thing that ever came out of New Jersey, besides John Rule, who went there for graduate school, and many others, I'm sure. So we New Yorkers like to make fun of New Jersey, as I said. But this telescope was not looking to discover the Big Bang. It discovered it serendipitously, by accident, looking to communicate with the first radio transmitters placed in space, the Telstar satellite, which was launched just a few years after Sputnik. This communications link was plagued by a background of excess noise that could not be removed in any season, any direction, any time of day. And that signal became known as the cosmic microwave background. Now, if you go out in any place in New Jersey and look up at the sky, this is what you see. You see this orange glow. No, you don't. But this is what you'd see if you had microwave eyes. And then if you could turn up the contrast and see if there are any fluctuations in this background signal, this is what you'd see. You'd see this colorful tapestry that we call the cosmic microwave background anisotropy. And one of the projects John Rule worked on, called Boomerang, first discovered some of the dominant signal in the modeling in this colorful pattern. And they make like stuffed animals out of this pattern. It's quite amazing. And for my 40th birthday, my wife decorated a cake with this pattern. And she got the power spectrum nailed down. It was perfect. Now, my friends at NASA animate this image and show if you could follow one of these fluctuations, one of these hot spots or cold spots in the microwave sky, for hundreds of millions and billions of years, you'd be pretty bored, okay? For the first couple 100 million years, nothing would happen. Then eventually, in one of these colder spots, the universe would gravitate enough matter that stars could form. And then stars could form into proto-galaxies, and then larger galaxies could form like the Milky Way. And then eventually stars like our sun would form out of the ash heap of a previous generation of stars called population 2. And those stars would provide the fuel for the Earth and the debris that surrounds us that we discover in the form of dust. And I'll talk a lot about dust because I think it is an incredibly overlooked substance. I never thought I'd write a book about dust. But then I also, how many of you hate dust jackets? I used to hate dust jackets because you read, the book falls out of it. I actually didn't want to have a dust jacket on this book. My publisher said, no way, you got to have a dust jacket on. And I realized, well, my book's kind of about dust. And then you read a book by Stephen Hawking about black holes and time warps, and I'd love to see a time warp cover, on the cover, but they don't make them. So I figured at least they're going to get some practical use. And my publisher says the next edition will have actual cosmic dust glued all over the cover. So look forward to that. So you buy 2 copies. No, don't wait for that. So the main question is, how did you get to this image, this colorful modeled pattern, if the universe started out and it was predominantly smooth? Well, that conjecture was sort of addressed in the 1980s by Alan Guth and other people, and it was realized that the universe had to start off with tiny fluctuations. And if the universe was pervaded by a quantum field called the inflaton, then that inflaton field would have tiny fluctuations, unavoidably, quantum mechanically, and those fluctuations would lead to the structures that we see today. So the logic is, if the universe started out pervaded by this tiny quantum field, these tiny seeds, just like a sequoia tree, grows to be massive, but the seed of a sequoia is very minute. So from a tiny seed, these huge fluctuations, these huge trees and structures can grow, and so too in the cosmos. So the cosmos could start off with tiny fluctuations, and they could be amplified to eventually make overdensities and make planets and people and performance halls like this. Now, what is that like in more human terms? So I always say this is a human embryonic stem cell collection. This is basically an embryo 1,000 seconds after conception. I won't make the joke about the Big Bang here, but imagine trying to figure out who this belongs to, or perhaps observing the person today, invert their visage today, and say, what do they look like when they were an embryo 1,000 seconds after conception? Could you do such a thing? Well, since you can't guess who this person is, yet I've added some distinguishing features. And of course, you can all guess this person is my children's favorite astronomer of all time, Neil deGrasse Tyson. You don't know how painful that is, people. Kids worship Neil deGrasse Tyson. So here Neil is. He actually just turned 60 years old, which is roughly 2 billion seconds old. So if you convert your age to seconds, you can feel really old if you like. Try to get into a bar doing that, and it won't be successful. But it would be clearly impossible to try to do this, right? If you were trying to look at someone who's 2 billion seconds old, wonder what they look like after 1,000 seconds of life, then you'd be kind of considered a crackpot if you tried to get a funding grant from the NIH to do that. But instead, we think we can do much more than that. Using a picture of the CMB, the cosmic microwave background, at an age of 500,000 years, extrapolate back 44 orders of magnitude more in time. We believe we can do that using what's called gravitational radiation or gravitational waves. Similar in spirit to the gravitational waves detected by LIGO in 2015. And these gravitational waves, if present, if inflation took place, would shake up the cosmic background radiation and cause it to have a particular type of polarization called B-mode polarization. Not important why we call it that. But nevertheless, this pattern could be detectable, we realized, back in 2001. And I pitched this idea to my postdoc advisor, late colleague of John and myself, named Andrew Lang at Caltech, and he jumped at the idea. I thought he was going to fire me. It would have been my second time being terminated within about a year, but you'll read about that story in my book. But the idea to do this, to go after the signal, was one that Galileo would immediately recognize. It's a refracting telescope. It just refracts microwaves instead of optical visible light. But Galileo, first of all, knew a lot about thermometry and cold temperatures. He complained about the coldness of the temperature of Padua in January. He built the Galilean thermometer. You've probably seen these with little jars of alcohol and oil that float to different heights when the temperatures change. But this telescope is a refracting telescope that refracts microwaves using lenses not of glass, but of high-density polyethylene. Very simple material used in milk jugs that you see a picture of there. And you can tell that you can see through such a lens made of this material, because if you've ever gone to go get the milk out of the refrigerator, you can actually feel it's cold before you touch it. And that means you're feeling heat, infrared radiation, which is invisible. So invisible light goes through this high-density polyethylene material that milk jugs are made up out of. And so we use that property and the fact that they refract and bend microwaves to focus microwaves from the Big Bang onto our detectors. That was it. Detectors are much more advanced than Galileo, or not much more advanced than Galileo's eyeball, much less advanced than a human retina, but nevertheless they have far fewer pixels, but they work using superconductivity. And the temperature of a superconductivity of a superconductor and its resistance are intimately related. So when a little bit of energy falls into a superconductor, it can become a non-superconductor, a conductor, or resistor. And doing that transition and playing some very clever games that were co-built by Jamie Bach and Andrew Lang and others at Caltech, these devices can be exquisite detectors of heat from the Big Bang. They can detect the most minute signals emanating from this purported epoch of inflation. And so we built this telescope, and we put it not on a rickety wooden and lead mount, as Galileo was using there. We put it on this big, massive 10,000-pound mount, and spontaneously acquired a Twitter account. And this telescope does everything that Galileo's did. In other words, you can point it left and right, up and down, but you could also spin it about the central axis of the telescope. And that was very important for looking for what we're trying to attempt to find is called polarization. And to do that, you need to spin the telescope around. So this massive telescope, thousands of pounds, can rotate, and it can spin, and it can locate itself and stop literally within a human hair's breadth. And it's been operating almost nonstop for the last 10 years at the South Pole. Now, why do we go to the South Pole? Well, there's the South Pole. It's at the bottom of the world, or the top of the world, depending on your perspective. It's always the part of the world on a globe that they put the stick that holds up the globe. It always gets literally the short end of the stick. But actually, it's one of the most beautiful places to go if you get there nowadays. It wasn't always such a great place to visit as these pictures depict. So 107 years ago, next month basically, expeditions came and reached the South Pole for the very first time. And there were two expeditions competing at the same time, very much reminiscent of the space race to reach the moon, or a race to get there first to discover something for the first time and win a Nobel Prize. I noticed many parallels between the two. And actually, these two teams were fighting, and they were aware of each other's progress, and they were trying to scoop each other to reach the South Pole first. Now, you see there were two different technological approaches here. So the upper team is the team led by Amundsen, a Norwegian explorer, who tried to get to the North Pole first and was beaten. And he immediately turned around, set his men, ships, and dogs, importantly dogs, down to the southern hemisphere to reach the South Pole first, 1910, 1911. The British used a much more a sophisticated form of transportation called the graduate student. No, they're not graduate students. These are far more valuable. No, these were his other men that were on the expedition. Now, why did they choose to do this? Well, they were proper British gentlemen. And British gentlemen knew that the Norwegians were going to eat the dogs. And in fact, they did. As soon as they got to the South Pole, they had a nice dinner of deep-fried dog or whatever they did, roast dog. And then to get home, they're actually able to ski downhill. It's about 8,000, 9,000 feet above sea level when you get to the South Pole. So skiing up, it's the hard part. Skiing down is easy. There's actually some wind that you get a little push from coming back down to where they left from in Antarctica. Now, when the British team, you can see, as John can verify, having been to the South Pole, when you get to the South Pole, it's basically like going out into the middle of Lake Erie, freezing it solid, outside of land sight completely, and you see nothing but flatness, whiteness, and waves of frozen snow. So you can see stuff that's really far away. So for days, they saw something sticking up out of the ground. Now, they didn't know, there was no Instagram, Amundsen, hey, we did it, selfie, No, they didn't know that they had been beaten. So they got to the South Pole, and they saw a Norwegian flag sticking up out of the ground. So what do? It kind of reminds me of like my little brothers when I would when I would get a high score in Tetris or whatever, back, they would immediately try to see that, I cheated or did something wrong. So the British went and they surveyed the site. They wanted to see, maybe they're off by 10 feet, and maybe we can claim we got to the South Pole. But they found out they actually were accurate, and as far as they could tell, that they had been beaten to the South Pole. And Scott famously declared, "Great God, this is an awful place, and all the more so for having reached it without the benefit of priority," meaning that it was almost like inconsequential to be the second person to make an achievement like this. Many of the experiments we did, I was talking with Professor Chotner earlier, many of the experiments that you had us do were basically Nobel Prize winning. I mean, we did the Michelson-Morley experiment in one of our labs. Now, that won a Nobel Prize in 1907. So it's amazing how quickly something goes from Nobel, nobody can do it, Nobel Prize worthy, to we're doing it in the lab, sometimes a few years after it was discovered. And so too with the South Pole, and so too with the moon. And I like to equate this discovery, so tomorrow a new movie called First Man comes out. There's been a lot of controversy about that movie because they don't show the American flag for some reason. I don't know, I haven't seen the movie, I want to see it. It looks really cool. But imagine yourself back in 1969 when astronauts landed on the moon for the first time, and Neil Armstrong gets out, and he's not the first man, he's the second man, and he puts the flag, oh my God, there's a Russian-Soviet flag there. Imagine how PO'd he'd be, right? I mean, this would be devastating that he could land and be second, right? So that's how it felt for them back then. And nowadays, all these guys died, okay? Sorry, they all died because they made a miscalculation. They took extra people because he was actually trying to be more inclusive and bring more men than he needed, which meant they ate more food, they used up their calories quicker, and they were more susceptible to injury just having more people there, and some of them got frostbite and slowed down the whole team. They ended up all dying within about 7 miles of their last supply cache of food and fuel that would have kept them alive. So a difference of 3 weeks, and the change in weather in a mere 3 weeks at the South Pole. They got there in January, Amundsen got there in December. That made a difference between life and death. Their bodies weren't discovered for several years afterwards. So it's still not the safest place to go to, as this video, very grainy, that I shot on my last expedition shows. So my 5-year-old always wants me to bring back a penguin when I'm there. So I figured maybe they just don't like people. Maybe penguins, they just don't like people. Maybe they're penguin people, they're not people. So I took another video just to give them the benefit of the doubt. And this is what I saw. So they're not the nicest creatures. So, we went out to dinner earlier tonight, and I was trying to figure out, do I want chicken or fish? Well, choose penguin. It's kind of like the perfect combination. Now, when you go there nowadays, it's so much easier. You get all your clothing needs, all your food needs, all your transportation needs all taken care of, courtesy of the U.S. government. So you go down there, you go to, and collect all of your clothing that you're going to need. If you're there, depending on how long you're there, if you're there for a whole year, so-called Winterover, you get to bring an extra bag, well, that's pretty nice, of clothing. And you get a boarding pass, and they sniff you for certain substances that they don't want brought down there to the South Pole. And you get on a plane, and hopefully you don't see this, although I saw this the first couple of times I went down to the South Pole. And you can see, this is a C-130 cargo plane. It's the workhorse of the U.S. Air Force. And this one has been sold to the New Zealand government. And the New Zealanders don't have many enemies, I figured out, because this is about 10% of their entire Air Force. You're looking at it. And then you can barely see it underneath the fuel tank that looks like a giant bomb. But there's a picture of their logo. And the United States Air Force, my stepfather was in the Air Force and he used to regale me, their logo is the screaming eagle, the falcon, the talons of raptors of death. What's the logo of the New Zealand Air Force? The kiwi bird, a flightless bird. That's what you get when you have no enemies. They're like the Switzerland of the Southern Hemisphere. Anyway, you get your clothes, and you get on your private limo to the South Pole. And the very front, you can see first class, then immediately next to it, business class, and then economy. No, it's all one class. There's almost no windows on the plane, you can see here. So good luck getting a window. There is one non-flushable toilet called the honey pot, for reasons I won't get into. And you get a bag of mystery meat of some form or another to sustain you, but it's only for 11 and a half hours. So that's not so bad. Yeah, you can do anything for 11 hours. Eventually you land in McMurdo, and finally you get to the South Pole, maybe a couple of days later, and you see your experiment, the one you've been pitching, trying to get funding for, battling with colleagues who say you're an idiot trying to build this experiment, no one's ever going to believe you, you can never do it, and you finally get to see this creation at the South Pole. It's really, for a kid who had a telescope since age 12, it was really just an incredibly proud moment for me to see the telescope located in the building we had at the South Pole. Of course, that was only after getting my luggage at the beautiful passenger terminal at the South Pole. On the left, you see the President's Club. The Admiral's Club is in the middle. Ambassador's Circle isn't. No, there's none of that. That's all you get. And remember, this is what Scott had to face, right? So he called it an awful place. Nowadays, it's much nicer, but this is them to scale. So remember, if you went out into Lake Erie and you froze it, flash froze it, and there was any wind whatsoever, there'd be waves of snow that froze into place. There's a name, Eskimo name, or Inuit name, it's called sastrugi. You know, they have names for millions of types of snow, and this means wave of frozen snow. And underneath these waves of frozen snow are caverns of ice that you can collapse and get sucked into and die. And they had to ski over it, but as I said, it was only for 700 nautical miles. Up 10,000 feet nearly above sea level. It's just astonishing that they did this. And they took this selfie. The guy in the lower left is holding a string to take this selfie and immediately upload to the cloud. Now, when I got there, I thought it was awesome. I also took a picture. And I said, this is an awesome place, not an awful place. This is my accommodations when I was there. It's actually as wide as my arms held outstretched, which is still smaller by a little bit than a California state prison cell. I noted that. The walls are made of cubicle material, so you can hear your neighbor's sleep apnea quite loudly and clearly. But it's pretty nice. The main downside is that it's light 24 hours a day. When I'm there, it's during the austral summer. So the sun is up 24 hours a day. It just makes a circle above your head. It drives you mad when you get up at 3 in the morning. Your body doesn't know. You have to go to the bathroom. And then you step out in the light, and you're just blinded by this incredibly bright, brilliantly bright light reflecting off this ice shelf that extends hundreds of miles in all directions. So here I am inside my dorm, and you can see the dome. There was a dome that used to be there in the back. And then here's the Bicep 2, the reason I was there. This is where the Bicep Observatory is. It's not that cone is not a collector of light. That's actually meant to keep the hot radiation from the surrounding cold, frozen polar plateau. It's still, even though it's so cold, it's actually much, much brighter than the signals we're trying to see. The reason we go down to the South Pole is shown in this image. So if you go out, I heard yesterday was a nice day. I don't know why you couldn't arrange for a nice day today, but anyway, it actually brings me back to most of the way I remember the weather being 25 years ago. But if you went out yesterday and you looked about this far above the horizon, you would see a sky that's almost kind of maybe bluish white, but mostly white. But at the South Pole, when you do that, you get this inky blackness of the sky. In fact, when you look straight up, it's almost like looking into space. And that's why we go there. There's very little water vapor in the South Polar atmosphere. Why is water vapor bad? Well, your microwave oven works by absorbing microwave energy from a generator inside the oven. And that generator generates microwave energy that vibrates and agitates water molecules so much that they start to boil. Which is why you can put water in a ceramic cup, put it in for 10 minutes. I don't advertise doing this out there. But you can put it in for many, many minutes. The water will become superheated, but you could still touch the ceramic because the ceramic has no water in it. So water absorbs microwaves. We don't want a water molecule a kilometer, 10 kilometers above the telescope to absorb this photon. Remember, this photon has been traveling for 13.82 billion years. We don't want the last millisecond of its life to get intercepted by a water molecule. So you want to go somewhere that's very dry. What's the driest place in the world? Well, it's not in the world, it's in space. But a space experiment we realized would cost 100 times more than building Bicep at the South Pole. So we decided to do it there. That's the building it's in, the second most important building at the South Pole. Okay, now remember, we're looking for this twisting pattern, this very twisting, swirling pattern of microwaves that would be indicative of gravitational waves, which themselves would be indicative of inflation causing the ignition of the Big Bang, if you like, speaking very loosely. And we claim we saw it. On March 17th, 2014, St. Patrick's Day, we announced to the whole world that we had detected this pattern called B-mode polarization, which meant effectively, as we claimed, a detection of the earliest physical epoch in the history of the universe, the inflationary epoch. And we got a lot of attention for it. Many people might recognize there was a video produced by Stanford University a few weeks before the announcement, and it showed one of the men who's considered the pioneer of the inflationary theory, Andre Linde, and his wife, Renata Kalosh, at Stanford University faculty, celebrating with one of our colleagues, Cha-Ling Kuo, and this video got 2 million views within an hour. So all around the world, people were tuning in to see what this announcement was all about. We had claimed we had witnessed a discovery that was clearly, as John said, Nobel-worthy, and people were talking about it instantaneously, but also that we had witnessed the earliest evidence in the history of the universe that could ever be gathered. So it was as big, if not bigger, than any discovery, according to many people, that had ever been made. So it's quite astonishing. There was a press conference that we had at Harvard. There were Nobel laureates in the audience of that press conference in front of presumed to be future Nobel laureates. And it made headlines all around the world. I'm sure the Plain Dealer covered it as well. It made the front page of the newspaper of record, the one that prints all the news that's fit to print. The San Diego Union Tribune, of course. There I am on the front cover looking up at a bunch of zeros that show how far back in seconds we had seen back to the beginning of time. And I like the headline on the bottom from the Economist, because it kind of sounds like there's just some dude and he's just looking out. Wow, the universe! Wow, that's awesome. But my favorite headline of all was in the true scientific journal of record. Of course, we all know what it is, The Onion. The Onion convened a panel of expert physicists, including Michio Kaku, and rhythm and blues R&B singers like Aretha Franklin, the late great Aretha Franklin, Smokey Robinson, and Diana Ross. And they debated the meaning of forever. And the caption underneath it says, "Panelists discuss whether it is theoretically possible to give you my heart forever." And the bottom one says, "We can observe long-term phenomena like the CMB, primordial B-mode polarization." They really said this. "And the love between India Arie and her man, all of which seem to have existed since the universe's infancy." Now, Nobel Gold for us, alas, was not to be. And we quickly came under criticism from many groups. Actually, within hours, people were criticizing our results, saying we had seen another type of signal that was unintentionally masquerading as a signal we were seeking, and that was called synchrotron radiation. Radiation from radio galaxy, radio pollution, spinning dust grains, etc. And they claimed that we had seen actually galactic dust contamination at low frequencies from radio sources. We quickly sprang into action, and we decided that that claim was without merit. And we actually disproved it within a couple of weeks, team members did. And so we rested comfortably, and I was reminded of this quote by Winston Churchill, who said, "There's nothing in life as satisfying as being shot at without result." So literally, we had dodged a bullet, and we felt even more confident that we were bound for this history book, the glory of Nobel Gold and the thrill of being correctly validated with this discovery. Later, it was discovered that actually we had seen the imprint of dust, and that this dust signal had masqueraded not at low frequencies, but at the exact frequencies we were measuring, and it only came about thanks to a collaboration with a competitor called a satellite called the Planck satellite. And these two teams, our team and their team, worked together to figure out that we had actually seen very accurately a signal from this very prosaic substance called dust. And the dust itself was caused from the same star that exploded to give life and give material to our solar system. The nebula that produced our planet was producing also amounts of dust, and throughout our galaxy as well. So we now know that the cosmos is not centered on us, but it's also not a very clean place. As I say, those of us from Southern California can attest, it's a very smoggy place. It's filled with dust, pollutants that are about a few hundred microns long that can become magnetized like microscopic meteorites. And just like a meteorite has magnetic properties, so too do these tiny grains of dust. They get aligned in the Milky Way's magnetic field and exactly mimicking an imposter signal of what we were trying to see. So our discovery literally went down to dust, but I don't want people to think that dust is all bad, because dust is us. So I wax poetically in the book, and I probably self-indulgently have a poem, but it's not as good as Carl Sagan's treatise on dust, where he said that the Earth is basically a giant ball of dust. So this picture is a selfie of the Earth taken by the Voyager satellite in 1990, on Valentine's Day 1990. They commanded Voyager to turn around and take a selfie of the Earth. And so if you're older, if you were born after February 14, 1990, you're in this picture in some form or another. A single pixel captured the entire planet, and it was bathed in light from the sun. And he poetically describes it as that dot is here, is home, is us. Every saint and sinner in the history of our species lived there on a mote of dust suspended on a sunbeam. It's pretty beautiful. It really means that the dust is us. The dust is our planet. Our planet is a giant ball of dust, and dust is ubiquitous. It not only causes the need for dust jackets, but it actually allows us to exist. So dust blew away our signal and blew away the Nobel Prize for many of us. But all was not lost, because just a matter of weeks later, after losing this closest encounter that I'm likely ever to get with the Nobel Prize, I came to my office exactly 3 years ago today. And I came into my office and I found this document waiting for me. And it said, Professor Brian Keating, we, on behalf of the Royal Swedish Academy of Sciences, we as members of the Nobel Committee on Physics have the honor of inviting you to submit a proposal for the award of Nobel Prize in Physics in 2016. And it goes on to say this. Now, by the way, please, please, I implore you, everyone watching on the internet, it says strictly confidential. Don't tell anyone. I could get in a lot of trouble. No, I put it in the book. So anyway, I think they're mad at me, but so far I've survived. The instructions that were given to me to make an invitation to nominate somebody set me on a path of inquisition as to the origins of the Nobel Prize and what was intended by the namesake creator of the Nobel Prize, Alfred Nobel. And I think it's pretty interesting when you look at it, how far it deviated, and that's what I'm going to get into. But to give you a sense of how humiliating, quite frankly, it was to do this, imagine you guys, so there are some of my brothers, my Phi Kappa Thetas out there in the audience. Imagine you didn't get accepted to CASE, and it was your dream school like mine. But the admissions committee, Dean Taylor and somebody else sends you a letter, the President Snyder, and it says, dear sir, madam, we regret to inform you you're not getting accepted to Case Western, but could you tell us somebody who deserves to be accepted to Case Western? I mean, that's the way it felt. This was my Nobel Prize, darn it. And to be asked to nominate somebody for it in place of myself, and it actually says, there's a special piece of the invitation, I'll show here, it says, you may not nominate yourself. So that was great, Even my ego is not that big. But I went back and knowing fluent Swedish, as I do, I mean, we all do here, we all learn it freshman year here, right? Okay. I looked at Alfred Nobel's will, and it's surprising, this thing endowed billions of dollars of prizes and attention. It's written by hand on what looks like to be a napkin. It was written in 1895, 7 years after his brother's misattributed obituary. Remember, they had already declared him dead once before. He sprang into action, took him 7 years, but he wrote down his will by hand. He wrote it down a year before he died. And we're in a synagogue, so I can't help but quote from the Talmud. The Talmud, Rabbi Tarfon says, repent 1 day before you die. Meaning, you don't know when you're going to die, right? So you should always be in this state. So he died almost exactly a year to the day after writing down this will. So it was very fortuitous for him. And so I don't speak Swedish, but I went through it, and they have a translation on the Nobel Prize website. And it says in the second sentence, I'll tell you what the first sentence says, a very egregious sentence that I'll explain later. But the second sentence says, the whole of my estate shall be distributed annually in the form of prizes to those who, during the preceding year, shall have conferred the greatest benefit to mankind, apportioned as follows. One part to the person in the singular, who shall have made the most important discovery and invention in physics. Okay, so there are three clauses. A single person who made the greatest beneficial discovery in the preceding year. And this sort of tweaked my curiosity, because I went back to the letter I received, and I redlined it, and it says, work done long ago may be selected in the award only on the supposition that its significance had until recently not been fully appreciated. And then they underline, they put in parentheses, candidates, plural. And they don't mention anything about the beneficence conferred by the discovery. So the only three things that Alfred Nobel wanted were either varied significantly or completely omitted in the instruction letter that I was asked to provide. I did more research. I asked the question, has anyone ever won a Nobel Prize the year after discovery that had a great benefit to mankind and was a single person? And what I found was quite interesting. So there are three different inventions or discoveries, all made during the Nobel Prize epoch, all eligible for Nobel Prizes, in other words, numbered 1, 2, and 3. I'm going to ask for a vote, show of hands. So number 1 is the RNA molecule, the precursor to life itself. Who thinks number 1 won the Nobel Prize at some point in the last 117 years? Okay, no, okay, yeah, good. Who thinks the periodic table, Mendeleev's creation, was eligible for the Nobel Prize for many years? Has element number 102 named anybody? No. 102? Nobelium. So there's an element named after Alfred Nobel. Who thinks number 2, periodic table, won the Nobel Prize? Okay, a couple brothers over there. Who thinks the Lighthouse won the Nobel Prize? And who does not like to raise their hand? Get them up high in the sky. Of course, it's the Lighthouse. I got here by Lighthouse. I mean, who didn't? John drove us here. He was consulting with the Lighthouse. He doesn't use Siri or, GPS. He used the Lighthouse to get everybody. No. Gustav Dalén, Swede. By the way, if you want to win a Nobel Prize, be born in Sweden because you have a higher chance per capita. He won it for invention of automatic regulators for regulating lighthouses and buoys. Very important. One for the ages, of course. He won it the year after its invention. He's a single person. Perfectly in accord with what Alfred Nobel wanted. Maybe not super useful to this very day, but nevertheless, it's not the only controversy that's beset the Nobel Prize. Here's another couple of examples. I won't comment on them, but there have been a lot of controversy associated with two Nobel Peace Prizes, at least. And then Bob Dylan didn't even show up to get his Nobel Prize in Literature 2 years ago. Nobody is going to show up this year on Alfred Nobel's death day. The prizes are given out December 10th, Alfred Nobel's anniversary of his death, not his birthday. Kind of weird, creepy, a little creepy. But Bob Dylan didn't even show up. This year, no one will show up because they canceled the Nobel Prize in Literature this year because of a sex scandal allegedly perpetrated by the husband of the secretary of the Swedish Academy of Literature that selects a Nobel Prize in Literature. In other words, her husband was having affairs with women who were maybe trying to incur favor to win Nobel Prizes in Literature for themselves and divulge information about the Nobel Committee, and she took the fall for it. And many people think that that's egregious oversight. And they may not give it away next year either. There's an investigations unit that normally investigates the Swedish mafia, and they're investigating the finances of the Literature Prize. So there's been a lot, and of course our dear leader is being in the running for the Nobel Prize. Not this year, he didn't win it this year, but he's been nominated for next year's Nobel Prize. And anybody can nominate people for the Peace Prize, so keep that in mind. I can even nominate myself. So what was the first sentence? I showed you the second sentence, and here's the first sentence. It says, I, Alfred Nobel, do hereby declare, after mature deliberation, declare the following to be my last will and testament. To my nephews, Jlamlar and Ludwig Nobel, I bequeath the sum of 200,000 crowns, and to my niece, Mina, 100,000 crowns. So what do you notice? The girl gets half as much as the guy. And until last week, the number of Nobel Prize winning women in physics could fit on this slide. These are the only two women that won the Nobel Prize in physics until last week, thank goodness. Marie Curie, and these two only won it after many, many decades and much arduous struggle. Marie Curie's husband, Pierre, refused to accept the Nobel Prize unless she won it. They didn't want to give it to her in 1903. But he refused to accept it unless she was awarded it. Maria Gephardt Mayer at UC San Diego, my home institution, won the Nobel Prize in 1963. And when she won it, her son told me the headline in the newspaper of record, said, San Diego housewife wins Nobel Prize. And for the next 54 years, no woman had won a Nobel Prize. And so I used to say, yeah, there's many women on the back of the Nobel Prize as have won the Nobel Prize. So there are two women on the back, Mother Nature and the genius of science, two goddesses. And then there's a guy in the front, and this is called the Bechdel test, I'm told. So when there's two women and one guy, they're always talking about a guy. But thank goodness last week, Donna Strickland won it. And of course, she won it for work done decades ago. And her advisor shared it with her, Arthur Ashkin. He's 96 years old. Many people thought, he was aggrieved by not winning it decades earlier when it was awarded for inventions and discoveries related to optical tweezers. But anyway, I thought it was a great change to the Nobel Prize, but it still endures as the symbol of almost exalted idolatrous nature. And I witnessed this firsthand. So on May 11th last year, Duncan Haldane, who had been a professor at UC San Diego in the 90s, he did work on topological states of matter that later resulted in the 2016 Nobel Prize, the year that I was nominating winners for the Nobel Prize. I did not nominate him. Don't tell him. He'll be mad. But no, he won't be mad. He came back on May 11th and gave a colloquium. And he brought with him his Nobel Prize. He never leave home without it. It's like American Express. And he brought it with him, and you can't even see it. One of the students is holding it, and it's glowing with this brilliant intensity of 1,000 suns. And professors came up to it and were touching it and taking pictures and kissing it and licking it and all crazy stuff with it. And I realized it's kind of like, again, we're in a synagogue, so I'm going to get a little biblical here. So I always thought, well, the story of the golden calf was kind of too strange to believe. So the Israelites leave Egypt, and God has these huge plagues, devastates Egypt. 40 days later, they make a cast golden statue of a calf, the so-called golden calf. I said, this is totally irrational. No one who had ever actually witnessed the miracles of Egypt being visited on the Egyptians would ever fall victim to making a calf out of gold and worshiping him themselves. That's ridiculous. But the most secular, maybe the most intelligent, rational people in humanity, at least people tell me so, are physicists. And yet even physicists couldn't resist coming up and touching this gilded graven image with a picture of Alfred Nobel on it that you have to bow down to on his death day to accept. It repulsed me. I actually felt physically sick that colleagues of mine would stoop so low as to worship an idol of gold that they had made themselves. It was revolting. It was disgusting. This was on the day I submitted the manuscript for this book. I'd been railing against the devil, and even I succumbed to its lustrous power. It shows you that we're not so far removed from these, 30th century BCE idol worshippers of yore. So it's a long tradition. Now, he's a wonderful man. I really enjoy him. But this is not only confined to the Nobel Prize. You may have heard that just recently in August, the Fields Medal, which is called, as you see in this article, it's often referred to as the Nobel Prize for Mathematics. There is no Nobel Prize for Mathematics. Nobody knows why. Some say it's because Alfred Nobel's wife was having an affair and had children with a mathematician, which is false on multiple accounts. He never married, had no children, and the woman was not related to him in any way. This award, the Fields Medal, is sort of called that. And minutes after it was given this past year, it was stolen. Why would you steal a thing? It's worth 15,000 Canadian. Okay, that's pretty good. But besides that, it's to get a piece. It's to get this posterity. It's to get this lustrous representation of the pinnacle of human mind. But why isn't the accomplishment, the science? I mean, the person who stole it's probably not going through the derivations that this gentleman went through to derive that actually won him the Fields Medal. It's because people want to attach themselves to a physical entity. It's a craving that many people have, including myself as a younger person. And despite all the tragic implications for the one who had his Fields Medal stolen, it actually gave me a great idea for my next book title. Of course, it will be Stealing the Fields Medal, okay? Had good success with losing the Nobel. Now the next book's coming out soon. I want to close with some suggestions for the future, and I'll take some questions and leave time for thunderous applause. But I do want to say, this quote from Gandhi really sums up my relationship with idols of gold, idols of dust, and essentially the humility that we need to have when we conduct ourselves as scientists. And Gandhi said that the seeker after truth should be humbler than the dust, because dust is crushed upon by human feet, but a human being should see himself as vulnerable to being crushed by dust. Only then, and not until then, will he have a glimpse of truth. This is his book, Story of My Experiments with Truth. Gandhi nominated for the Nobel Prize 13 times, never won it. Hitler was nominated once, of the despicable memory. And I do want to just point out that, he never won it. Gandhi never won it, even though he contributed such tremendous benefits to the world in avoiding perhaps what would have been one of the bloodiest conflicts in history. So on the science side, I've come to not regard the Nobel Prize as the be-all and end-all of my career, but instead working with colleagues, 244 of them, not just one of them, working on a project called the Symons Observatory, which is a very ambitious project, as John pointed out. I spoke about earlier, and there's information on the web about it. It's a massive telescope that's going to be observing the southern hemisphere, looking for the echoes of creation, and looking for dust. To get rid of dust, you must think like dust, and you must outsmart the dust, which is harder than it sounds. So the final sentence of Alfred Nobel's will has always intrigued me. He suffered from a terrifying fear that he would be buried alive. And it's actually a psychological condition that's called Tappaphobia, the fear of being buried alive. And his final sentence of the will says, finally, it's my express wish that following my death, my veins shall be cut open. And when this has been done, and competent doctors have confirmed clear signs of my death, by the way, if his veins are cut open, I mean, he's going to be dead, but if he really wanted to be dead, because look at the next, my remains shall be cremated in a so-called crematorium. So he's really dead. This guy wanted to be dead. He actually invented a series of tubes that could transport coffins beneath the streets of Stockholm that would have bells in them that could be rung if people were still alive there. But I actually don't know if they actually followed through with his wishes, because they violated so many other things in his will. I wonder if they actually did this. But I thought it was important to open the veins on the Nobel Prize process. And so we created a website called losingthenobelprize.org, where you can vote on changes or people you think should win the Nobel Prize. So down there you see Jocelyn Bell has received, it's kind of like moveon.org for super nerds like me. And we voted on people that should deserve the Nobel Prize. And actually, Jocelyn Bell was one of the top vote getters, and she just won the $3 million Breakthrough Prize for her discovery of pulsars that awarded a Nobel Prize to her male PhD advisor in 1974. So hopefully we can rectify that situation. Just remind you, last day to register to vote, so to vote for the Nobel Prize and vote in Ohio as well. And I'll leave time for questions. Thank you very much.